Welcome to the channel. Today, we're diving deep into the world of networking protocols, the unsung heroes of the internet. We'll break down some of the most common protocols you encounter every day, like HTTPS, SMTP, HTTP, DNS, TCP, UDP, and DHCP. So, buckle up, grab your favorite drink, and let's get started. First up, we've got HTTPS, the protocol that keeps your online activity safe and sound. It's like a digital bodyguard for your data. You see that little lock icon in your browser's address bar when you're shopping online or checking your bank account. That's HTTPS working its magic, ensuring your data is secure. HTTPS stands for Hypertext Transfer Protocol Secure. It's a mouthful, but it's crucial for online safety. The S in HTTPS signifies that the communication between your browser and the website you're visiting is encrypted. Think of encryption as scrambling your data into an unreadable mess before it's sent over the internet. It's like turning your information into a secret code. Only the intended recipient with the right decryption key can unscramble it and make sense of it. This ensures that your data remains confidential. This prevents hackers from eavesdropping on your conversations and stealing sensitive information like passwords and credit card numbers. It's like having a secure vault for your data. HTTPS also verifies the authenticity of the website you're connecting to. It ensures you're talking to the right website and not an imposter. With HTTPS, your browser checks the website's security certificate to make sure it's legitimate and issued by a trusted authority. This adds an extra layer of trust. So, next time you're browsing the web, make sure you see that little lock icon and the HTTPS in the address bar. It's your sign that your data is in good hands. Next up, let's talk about SMTP, or Simple Mail Transfer Protocol, the protocol that makes email possible. Every time you hit send on an email, SMTP works behind the scenes to deliver your message to its destination. Think of SMTP like a postal service for the digital world. It takes your email, wraps it up in a digital envelope, and figures out the best route to deliver it to the recipient's inbox. When you send an email, your email client, like Gmail or Outlook, connects to an SMTP server. This server acts like a post office, checking the address, adding any necessary stamps, metadata, and sending your email on its way. SMTP uses a system of commands and responses to ensure that emails are sent and received correctly. It's a bit like a conversation between two computers, with each side acknowledging receipt and confirming delivery. So the next time you fire off an email, remember SMTP, the protocol that makes sure your message gets where it needs to go. Now, let's talk about HTTP, or Hypertext Transfer Protocol, the foundation of the World Wide Web. HTTP is the language that browsers and web servers use to communicate and exchange information. Every time you type a website address into your browser and hit enter, you're initiating an HTTP request. Your browser sends this request to the web server hosting the website, asking for the website's files. The web server then responds to your request by sending back the necessary files, including HTML, CSS, JavaScript, and images, which your browser then uses to render the website on your screen. HTTP is a request-response protocol. This means that for every request your browser makes, the web server sends back a response. These responses include things like status codes, which tell your browser whether the request was successful or not. HTTP is a stateless protocol, meaning that it doesn't remember your previous requests. So the next time you're surfing the web, remember HTTP, the protocol that makes it all possible. Chapter 4. DNS, the Internet's Phonebook. Ever wonder how your computer translates those easy-to-remember domain names like google.com into the complex IP addresses that computers use to communicate? That's where DNS, or Domain Name System, comes in. Think of DNS as the Internet's phonebook. It keeps a record of all domain names and their corresponding IP addresses. When you enter a domain name into your browser, your computer first contacts a DNS server to look up the IP address. If the DNS server has the address in its cache, it will provide it to your computer, and your browser can connect to the website. But if the DNS server doesn't have the address, it will query other DNS servers until it finds the correct one. Once your computer has the IP address, it can establish a connection with the web server and start downloading the website's files. So, the next time you effortlessly type in a website's name, give a little nod to DNS, the unsung hero of internet navigation. Chapter 5. TCP, the Reliable Workhorse. Now let's talk about TCP, or Transmission Control Protocol, one of the most important protocols in the Internet Protocol Suite. It's the backbone of reliable communication on the Internet. TCP is responsible for reliable, ordered delivery of data between applications running on different computers. Without it, our online experiences would be chaotic and unpredictable. Think of TCP as a meticulous courier service that ensures your packages arrive at their destination in perfect condition and in the correct order. It's like having a personal assistant for your data. TCP establishes a connection between two devices before any data is exchanged. This connection is like a handshake, confirming both parties are ready to communicate. Once a connection is established, TCP breaks down the data into smaller packets and numbers them sequentially. This ensures that even if packets take different paths, they can be reassembled correctly. As the packets travel across the network, TCP keeps track of them and checks for any errors or missing packets. It's constantly monitoring the journey of your data. If a packet gets lost or arrives out of order, TCP requests a retransmission, ensuring that all the data arrives intact. This process is crucial for maintaining data integrity. This reliability makes TCP ideal for applications where data integrity is crucial, like web browsing, email, and file transfer. It's the unsung hero of our digital lives. So the next time you're streaming a movie or downloading a file, remember TCP, the protocol working behind the scenes to ensure your data arrives safely and soundly. It's the reliable workhorse of the Internet. Chapter 6. UDP, the Speed Demon. In contrast to TCP's meticulous approach, we have UDP, or User Datagram Protocol, a connectionless protocol that prioritizes speed and efficiency over reliability. Think of UDP as sending a postcard. You drop it in the mailbox, and it gets delivered eventually, but there's no guarantee it will arrive or that it won't get lost or damaged along the way. Unlike TCP, UDP doesn't establish a connection before transmitting data. It simply packages the data into datagrams and fires them off without any handshaking or error checking. This makes UDP much faster and more efficient than TCP, as it doesn't have to waste time setting up a connection or waiting for acknowledgements. However, this speed comes at the cost of reliability. UDP doesn't guarantee delivery, and it doesn't check for errors or lost datagrams. So the next time you're watching a live stream or playing a fast-paced online game, remember UDP, the protocol that keeps things running smoothly. Chapter 7. DHCP, the Network Organizer. Finally, let's talk about DHCP, or Dynamic Host Configuration Protocol, the protocol that simplifies network management by automatically assigning IP addresses to devices on a network. This is crucial in today's world where we have numerous devices connecting to the Internet simultaneously. Think of DHCP as a network administrator that never sleeps, constantly making sure every device on the network has a unique IP address so they can communicate with each other. It's like having a diligent traffic cop directing data traffic efficiently. Without DHCP, you'd have to manually assign a static IP address to every device on your network, a tedious and error-prone process. Imagine having to do this for every smartphone, laptop, and smart device in your home or office. DHCP automates this process, making it much easier to add or remove devices from your network without any hassle. This automation is especially beneficial in large networks, such as those in corporate environments or public Wi-Fi hotspots. When a device connects to a network that uses DHCP, it sends out a broadcast message requesting an IP address. This is the device's way of saying, "Hey, I need an address to join the network." The DHCP server on the network receives this request and assigns an available IP address from its pool of addresses. This process happens in a matter of seconds, ensuring seamless connectivity. The device then uses this IP address to communicate with other devices on the network and access the Internet. This dynamic assignment is what keeps our digital lives running smoothly. So the next time you connect your laptop to a Wi-Fi network and it magically gets an IP address, remember DHCP, the protocol that makes networking a breeze. It's the unsung hero of our connected world. Outro, stay connected, and that's a wrap. We've covered a lot of ground today, from the security of HTTPS to the speed of UDP and everything in between. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more tech insights. Until next time, stay curious.